Right, so let's go through this question 6, the 2024 A-level question. So a tennis ball of mass 0.06 kg traveling horizontally in a straight line and of course at a speed of 19 meter per second. After hitting the tennis racket, the ball actually travel vertically upward at a speed of 30 meter per second as shown in the diagram, right? So the ball is then in contact with the tennis racket for a time frame of 16 milliseconds. So this is your delta t. So the very first part A, we are asked to calculate what is the increase in the Ke of the tennis ball. This one is simple. So we just calculate what is the initial Ke. Then after that, we calculate what is the final Ke, right? Of course, 27 minus of 10.83 will give you about 16.2 joules. Alright, so let's move on to part 2. This one is the hard one. So part 2, the magnitude of the average force of the tennis racket on the ball. Okay, so first you realize that there's the ball is traveling horizontally, and then after that it's being hit up, right, at a speed of 30 meter per second. So what we can conclude is that there will be two forces. The first force will be horizontal, the second force will be vertical. Okay, let's take a look at the first part first. Okay, the first part, when the ball is hit, right, so there will be the tennis racket will actually exert a force right here on the tennis ball. So how do I actually calculate what is the force? Very simple. Just remember F equal to delta P divided by delta T. So of course delta T we know is 16 milliseconds. So it's like that. So what is the delta P? Okay, delta P is the change in the horizontal momentum. So initially, right, you can see that initial momentum, so it's towards the right hand side. So the initial momentum, let's just say, is 0.06 multiplied by 19, right? So it's about 1.14 towards the right. So this, maybe I just put kg meter per second. So if you realize one thing is that after the impact, there's no more horizontal momentum. So means I can conclude one thing is, the final horizontal momentum is 0. So of course, what is the delta P, right? Delta P is equal to final minus initial momentum. So this will give you 0, then this will become 1.14, right? So definitely you will get about negative 1.14. So the so-called delta P is negative 1.14. So let me just submit. So this will be negative 1.14. Of course, you just need to get the magnitude because the negative just annotate that the force is exerted towards the left-hand side. So this 1.14 divided by 16 millisecond. So this is about 71.25 like that. So it's 71.25 Newton. So this part right here, right, is 71.25 Newton. Okay, so let's take a look at part, not part 2, the second part, right? So realize one thing is that there's a momentum upwards, vertically upwards. Okay, so initially, when we look at the diagram, right, there shouldn't be any vertical momentum. So I can safely say that the initial vertical momentum is actually 0. Then of course I hit up, right, the final momentum is just equal to 0.06 multiplied by 30. So this will be the final momentum, 0.06 times 30, right? So it's about 1.8 kg meter per second. Okay, so definitely, what is the change in momentum in the vertical direction? The change in momentum is equal to final minus initial. So final minus initial, right, is 1.8 minus 0. So this will become 1.8. So of course it's a positive value. So okay, let me just write here. So you can see that when I heat up the tennis racket actually exert an upward force on the tennis ball. That's why it's a positive value. So F equal to delta P divided by delta T, right? So delta P itself is 1.8. Delta T is 16 times 10 negative 3. So this will give me about 1.8 divided by 16 times 10 negative 3. So it's about 112.5. Okay, so this 112.5, of course, just take note that it's not the force that the tennis racket actually exert on the ball, because remember, for this force, it's actually what we call the resultant force. So of course, maybe I draw the free body diagram of the tennis ball. So the tennis ball, right, actually have a weight, so mg, right, then of course have a so-called contact force or the impact force by the tennis racket. So this one is the force that we want to calculate. So maybe I just call it X lah. Maybe I just call it N. Maybe, yeah. So this N. Okay, so of course my resultant force is upward right of 112.5 Newton. So now we know that the mass itself is about 0.06. I simply just calculate what is the weight first. So the weight itself is about 0.06 multiplied by 9.81. So about, give or take, 0.5886 Newton. So quite small to be frank. So what is the so-called contact force of the racket on the tennis ball? So it's just so it's just x minus 0.5886, right, equal to 112.5. So it's as good as saying 112.5 plus 0.5886. So it's about 113.0886 Newton. Okay, so these are the two forces. Of course, I I draw the full thing. So the first horizontal force, right, will be about 71.25 Newton. There's an upward force which is about 113.0886 Newton. So definitely, right, what is the magnitude of the average force? So what they actually want is actually the so-called the diagonal force here. So I want to resolve I want to combine the two forces, right, the horizontal and vertical, such that I will get this diagonal force, or what I call the resultant force. Okay, so definitely I simply just use your Pythagoras theorem. So let's call this average force. Average force, right, is actually equal to square root 71.25 bracket square plus 113.0886 squared. So this will lead you to about square plus 3.086 bracket square. Okay, so I'll get a value of 133.6622383. So I just round off to 134 Newton. So the average force acting on the tennis ball will be 134 Newton. Alright, so that is how we actually do the part 2. Quite hard to be frank. Okay, for part B, suggest two reasons why the work done by the tennis racket, right, during impact is greater than the answer given in A part I. Okay, A part I, we actually calculated the increase in K to be 16.2 joules. So definitely, right, the work done, because I must do some work to cause the tennis ball to increase in your KE. So definitely the work done by me, right, must be more than 16.2, due to the fact that if you look at this tennis ball, it's like going upwards. So if it's going upwards, means there's an increase in GPE. So that's the first reason. And definitely, right, there's another reason is due to the fact that maybe you need to do work against air resistance. So these are some of the reason why your work done by the force will be greater than the 16.2. So let me just write down. So the work done by the force, right, work done by the tennis racket is actually equal to the increase in KE of the tennis ball plus increase in GPE plus the work done against your air resistance, A dot R. Okay, so the first reason, because there's an increase in GPE of the tennis ball. Okay, second reason is because there's some work done against air resistance. Yep, so that is how we actually do this question.